Hey everyone, and welcome back to the channel. Today, we're taking a deep breath and diving into something we often take for granted, the very air that surrounds us. We're going on an incredible journey from the ground beneath our feet to the edge of space, exploring Earth's amazing atmosphere. It's this invisible, life-giving ocean of air that makes our planet a vibrant, living world. So, what exactly is it made of? And how is it structured? Stick around, because by the end of this video, you'll look at the sky in a whole new way. Let's start with the basics. What are we actually breathing? You might think it's mostly oxygen, but that's only part of the story. The vast majority of our atmosphere, about 78%, is actually nitrogen. It's a crucial element for life, especially for plants. But in its gaseous form, it's mostly just hanging out. The oxygen we need to survive makes up about 21% of the air. That's the stuff our bodies use to turn food into energy. So, what about the remaining 1%? Well, that's where things get interesting. This tiny fraction is a cocktail of different gases. The most abundant of these is argon, a noble gas. But also in that 1% are trace amounts of other gases that have a huge impact. Like carbon dioxide, which plants use for photosynthesis and which plays a major role in regulating our planet's temperature. There's also neon, yes, the stuff in the signs, helium, methane, and, of course, water vapor, which is essential for clouds and rain. It's this precise, delicate balance of gases that has allowed life to flourish on Earth for billions of years. Think of it as Earth's unique recipe for a habitable planet. Now that we know what it's made of, let's talk about how the atmosphere is structured. It isn't just one big, uniform bubble. Instead, it's neatly organized into 5 distinct layers, stacked on top of each other like a giant, invisible layer cake. Each layer has its own unique characteristics, temperature profile, and role to play. We'll start from the ground up. The first layer, the one we live in, is called the troposphere. The word tropos comes from the Greek word for turn or change, which is a perfect description because this layer is where all our weather happens. It's a turbulent, dynamic place. The troposphere starts at the Earth's surface and extends up to about 8 to 15 kilometers, or 5 to 9 miles. It's thickest at the equator and thinnest at the poles. As you go higher in the troposphere, the air gets colder. If you've ever climbed a tall mountain or looked out an airplane window, you've experienced this firsthand. This is because the ground absorbs the sun's energy and heats the air above it. So the farther you get from the ground, the cooler it becomes. The troposphere contains about 80% of the atmosphere's total mass and almost all of its water vapor. That's why we see clouds, rain, snow, and storms exclusively in this layer. Commercial jets typically fly at the very top of the troposphere to stay above the turbulent weather, giving you that smooth ride. Just above the troposphere, we find our second layer, the stratosphere. This layer extends from the top of the troposphere up to about 50 kilometers, or 31 miles, above the ground. The stratosphere is a much calmer place than the troposphere below. There's very little weather here because the air tends to flow in horizontal layers, which is where the name strato comes from. But what's really fascinating about the stratosphere is its temperature trend. Unlike the troposphere, as you go higher in the stratosphere, it actually gets warmer. Why? The answer is one of the most important features of our atmosphere, the ozone layer. This special layer of ozone gas, a molecule made of 3 oxygen atoms, is concentrated in the stratosphere. It acts like a planetary sunscreen, absorbing most of the sun's harmful ultraviolet, or UV, radiation. This absorption process releases heat, which is what warms the stratosphere. Without the ozone layer, life on Earth's surface would be exposed to dangerous levels of UV radiation, making it impossible for most life forms to survive. So, you can thank the stratosphere for protecting you from a nasty sunburn every time you step outside. Moving upward, we enter the third layer, the mesosphere. The mesosphere stretches from about 50 kilometers to 85 kilometers, or 31 to 53 miles, above the Earth. Meso means middle, and this is indeed the middle layer of our atmosphere. In the mesosphere, the temperature trend reverses again. As you climb higher, it gets incredibly cold, dropping to as low as minus 90 degrees Celsius, or minus 130 degrees Fahrenheit, at its very top. This makes the mesosphere the coldest place in Earth's atmosphere. It's so cold that the tiny amount of water vapor present can freeze into ice crystals, forming what are known as noctilucent or night-shining clouds, which are sometimes visible from the ground after sunset. But the mesosphere has another critical job. If you've ever seen a shooting star, you've witnessed the mesosphere in action. Most meteors, which are small rocks and debris from space, burn up in this layer due to friction with the air particles. It acts as a protective shield, vaporizing tens of thousands of potential impactors every single day. So, the next time you make a wish upon a shooting star, remember to thank the mesosphere for doing its job. Above the mesosphere lies the thermosphere, the fourth layer. The thermosphere is a layer of extremes. It starts at about 85 kilometers and extends all the way up to 600 kilometers, or about 372 miles, and beyond. The name thermo means heat, and this layer lives up to its name. The temperatures here can skyrocket, reaching up to 2000 degrees Celsius, or 3600 degrees Fahrenheit. But here's a mind-bending fact. Despite the high temperature, it wouldn't actually feel hot to you. How is that possible? Temperature is a measure of how fast particles are moving, and in the thermosphere, the sun's high-energy radiation makes the gas particles move very, very fast. However, the air here is incredibly thin. We are getting very close to the vacuum of space. The particles are so far apart that there aren't enough of them to transfer that heat to you. The thermosphere is also where some of the most beautiful celestial phenomena occur. The incredible light shows of the aurora borealis and aurora australis happen in this layer when charged particles from the sun collide with the gas atoms in our atmosphere, causing them to glow. It's also the layer where the International Space Station and many other satellites orbit the Earth. Finally, we reach the outermost layer of our atmosphere, the exosphere. Exo means outside, and this is the final frontier between our atmosphere and the vastness of space. The exosphere starts at the top of the thermosphere and gradually fades away into the vacuum of space. There is no clear upper boundary. The air in the exosphere is so incredibly thin that it's barely there at all. It's mainly composed of the lightest gases, hydrogen and helium, and the particles are so spread out they can travel hundreds of kilometers without bumping into one another. Atoms and molecules in the exosphere are so far apart and moving so fast that some of them can escape Earth's gravity altogether and drift off into space. This layer is essentially the atmosphere's slow, gentle leak into the cosmos. It's the very edge of our world, the final, faint whisper of our planet's breath. So, why is this entire atmospheric system so important? Well, as we've seen, it's more than just the air we breathe. First and foremost, it provides the oxygen we need for respiration and the carbon dioxide plants need for photosynthesis, the very foundation of most life on Earth. Second, it acts as a protective shield. The mesosphere burns up meteors, and the stratosphere's ozone layer blocks harmful UV radiation. Third, the atmosphere regulates our planet's temperature through the greenhouse effect. Certain gases, like carbon dioxide and water vapor, trap heat from the sun, keeping our planet at a comfortable, stable temperature. Without our atmosphere, Earth would be a frozen, lifeless rock with extreme temperature swings between day and night, much like the moon. It's this blanket of air that makes Earth just right, from the weather in the troposphere to the auroras in the thermosphere. Our atmosphere is a dynamic, complex, and absolutely vital system. It's our shield, our blanket, and our life support, all rolled into one. So there you have it, a journey through the layers of Earth's atmosphere. It's an incredibly complex system that works tirelessly to protect us and make life on this planet possible. The next time you look up at the blue sky or see a shooting star, you'll know a little more about the amazing invisible world above us. Thank you so much for joining me on this atmospheric adventure today. I hope you found it as fascinating as I do. If you enjoyed this video and learned something new, please give it a thumbs up. It really helps the channel. And don't forget to subscribe and hit that notification bell so you won't miss our next exploration. What other science topics would you like to see? Let me know in the comments below.